Welcome back. When we left off, I had desoldered the original microcontroller from the playfield circuit board and wired in my microcontroller by soldering wires directly to the original micro's pads. I was able to control the back box, including the score digits and some lights on the playfield, but I also managed to destroy, well, not completely destroy hopefully, but lift every pad that I touched. So I figured that wasn't the right way to do things, and probably the next step would be for me to design my own circuit board that connected to the original microcontroller's pads the same way that this board did.
So to avoid causing any more damage like this, I set out to design my own PCB that could fit over where the old microcontroller went, so in this area here, that had connection points that I could solder on to these pads where the old microcontroller connected, and then broke out header connections or something like that that I could either solder wires directly to or connect a cable to, that would give me access to all of these signals on all of these pads without having to solder directly to them, which is how I wrecked these pads here. So the new board had to be sized approximately the same as the old microcontroller. I've got a little bit more space up in this area above the old where the old microcontroller sat, but I really can't go any further left or right of it because I need to match these pads here, and I can't go any further down because I've got these jumpers here that are flush mounted to the old board, so my board couldn't sit on top of those. So a little bit more space above, but otherwise I'm kind of restricted to this footprint. So I took some measurements and figured out the dimensions that my board had to fit within, and figured out the spacing of these pads, which isn't quite the normal 100,000ths of an inch that you find on breadboards. And I designed my own PCB here. So you can see this yellow line is the edge of the board, and then I've got castellated vias here on the sides that line up right with those original pads the original micro connected to. And then I broke out 3 different ways that I can connect to this board. So I've got, on each castellated via, I've got a small plated through hole that I could connect to. And then inside of that, there's header connections where I could wire breakaway headers to. And then inside of that, in the middle, I've got surface mount pads that I could connect a 30-pin connector to. So here's kind of what it should look like. See, I've got castellated vias down the sides, and it's shown here with the breakaway headers installed. But I don't think I'm going to use those. I'm hoping what I can do is connect a 30-pin header to here, and then use a ribbon cable to get to another board somewhere else where my own microcontroller would be. It's a little bit weird in this picture because the castellated vias, well, they're not castellated, because during fabrication, when they make this cut, they'll cut the half of the plated through hole away, and all you'd be left with is the inner half. So that's how they get castellated. But this is what it should look like. It's got connections for each of the 30 pins that the original microcontroller connected to, and it offers a much easier way to access each of those pins. And I should be able to, as long as I don't use these breakaway headers, which I don't plan on using, I should be able to flush mount it and then just surface mount a header rectangular connector here to break these pins out into a ribbon cable. I used KiCad to create this. I won't go into too much depth about how I did that because I'm not really familiar with the program enough to give a tutorial on it. But there are some great tutorials that I found really useful on YouTube that I'll link to in the description. And if you look at my getaway tachometer videos, in one of those I did a kind of a walkthrough of how I designed that PCB using DesignSpark, which is another electronic design application, and they're pretty similar. I kind of think once you learn one of them, then newer ones are easier to learn. Back when I did that getaway tachometer board, I don't know if KiCad didn't exist or if it just wasn't popular yet, but KiCad really seems like it's the go-to choice when you're making PCBs now, and I really enjoyed using it, and it was pretty easy to lay this board out. I just made a basic schematic. You can see here is the 30 pins on the outside of the board, and then my two breakaway connector for the headers here, and then the single 30 pin surface mount component. Just wired those up and then designed a PCB around it. But watch those KiCad tutorials, they're pretty nice. KiCad is becoming so popular that some of the board fabrication houses take KiCad files directly, so you don't have to convert them to Gerber or Eagle files. So I looked for a fabrication house that would take the KiCad files, and I found Osh Park. I hadn't used them before. The boards I made previously I've either sent away to China or Germany to have fabricated. But Osh Park is based in the US, and I'm glad I used them because they shipped a lot faster, and their communications are really good too. I got status updates all the time, and as soon as I uploaded the files, it gave me this picture, so I could ensure that it looked the way I expected it to. So I uploaded my KiCad files to Osh Park's website. It cost about $10, and within a couple weeks, I received my new PCB that I designed. So you can see it has just about the same pad spacing as the original microcontroller does, and it's the same width as the original micro. Like I said, I had a little bit of room above the micro to expand a bit, and that gave me some more space for a slightly larger footprint for the rectangular connector. Aside from that rectangular connector, I've got my 2 rows of 0.1 inch breakaway header through holes, and then really small through holes next to the castellated vias. So those surface mount pads in the middle are designed to fit a 30-pin rectangular connector like this one. It looks a lot like the connector that old IDE drives used to use in computers. But anyway, it sits right on top of those pads like that, and it's not it's totally surface mount. There's no through hole parts, so this board can sit right on top of the old micro footprint and not have any through hole components poking through and making contact with the playfield PCB. And then once I have that soldered on there, I can use a ribbon cable like this one, which admittedly is quite large and kind of unwieldy, especially when there's not a whole lot of room inside here. But 30 pins is a lot. and I'm not aware of any better cables that I can use. But this will fit right into there, and then I'll have to find some way of wrapping this around to get to wherever I can store my micro inside the cabinet. But in the meantime, hopefully I can just slip some wires on top of these pins to get access to each of these signals from the playfield board, and then connect it to my micro on the breadboard. And here's the footprint of the original micro. You can see the carnage I left behind. Hopefully those pads still work out. But you can see it's aside from the pads being raised and the traces lifted, so it doesn't sit quite flush right now. Hopefully that smooths out when I hit it with some solder. But you can see this lines up pretty good. Let's see if I can get it lined up. Could have been maybe a little bit wider. See if I can get it to work. The tolerance on the cuts isn't too precise. Oshpark warned me about that. I maybe should have made it just a little bit bigger. Better to be too big than too small, and I really didn't think about that when I made it. But it seems to fit pretty well. There's the new board compared to the original microcontroller. See, it lines up really nice. Each of these castellated vias on the side is connected to its own breakaway header pin and pad. I had to check Oshpark's website to make sure they could do castellated vias, and they could, obviously, because they did it for me. They had some caveats. They had to be vias. They couldn't be through holes, and there was some specifics on the dimensions of where they could be and what pads could be near them. And then they said there would have to be some manual work after. You can see there's some burrs, like on those two pads there. And then just in general, there's several burrs from the way they panel all the boards they make. So there's some things that I have to file off on the bottom and on the edges. Let's take a closer look at those vias. So I'll have to get a hold of some a small file and see if I can get those burrs out like that one there. Some of them are okay. But you can see how the through hole bent into the via when they cut it. So a little bit of work to make those right. So I've got this file set. Hopefully I can use these for the vias and also for the burrs on the edge of the board. think this is as small as I've got. That's rounded. Yeah. So I'll see if I can get that into the vias. Oh, that looks pretty good, I think. Next thing I want to do is get this rectangular connector soldered onto these pads here. I want to do that before I solder the castellated vias to the board. Just because I think it'll be easier. So I've never actually soldered a surface mount thing like this before. I think I'm going to just put some solder on one of these pads, get this lined up right, get it soldered down, and then let that cool so it stays where it is, and then just try to hit every pad. There's 30 of them. It's a lot. Alright, so we'll see how that goes. Alright. Just hit this pad first. Hopefully that's good. See if I can get this lined up. That's pretty good. Alright. Let's try and hit all of these. We miss. Looks like I'm hitting the through hole just as much as I'm hitting this pad. The pad that I'm trying to hit, all the through holes are really close. I think maybe if I had to do this over again, I would put them farther away from the pad. Alright, that looks like one side. Let's see. This side, I'm going to have to hit all these with connectivity. Make sure that they're actually soldered on there well. Let's take a close look here. Oh yeah, I filled in those through holes, didn't I? Lots of them. I think if I hit them with solder, I can open them up and still use them. But they were just so close to those pads. Alright, well I think I'll do connectivity on all these just to make sure. Alright, nice. Alright, next up, it's time to attach this to the playfield. I really did a number on these pads, and I wish I had made this board a few mils wider. It is just wide enough to touch the pads on both sides. Just barely. And it's going to be tough to get the solder to bridge across, I think. If I were more patient, I would redo this board and make it wider. But I'm not more patient. So I'm going to go ahead and do it. take a closer look here. Those look pretty good. I think that's BP27. I may have just barely caught that, the last amount of pad that was there. Right there was only a little bit of pad right on this side of it. Only a little bit of trace, sorry. Left where the pad was. And I might have caught it. The rest of these look good. All right, well, let's do a continuity check on all of these. I've got my original circuit diagrams. Should help me figure out where all of these pads go to. Alright, let's do the SPI. They go to, so we're talking about, I really should rotate this the way that it was when I took these pictures. All right. Second from top should go to fifth. All right, well, I think, so all of those checked out. I do want to check to see, to make sure I don't have any bridges across here. And I want to make sure, this is the one that's nasty. I want to make sure I got that one right. In fact, let's take a look at what that is. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Motor enable. Alright, well I did check that one. But let's just make sure. 7th pin, 1, 2, 3, 4, 5, 6, 7. So this is the one I was really worried about. It goes to R43, which is here. Nice. Alright, well hopefully that connection is solid enough. Alright, well I think I'm going to run down each of these and make sure there's no bridges. Alright, that that's interesting. So that is 1, 2, 3, 4, 5, and 6 up. 2, 3, 4, 5, 6. Oh, ground and BP07. Oh, well, that one might actually be shorted together, right? Let's take a look at that EEPROM connection. I didn't really understand this too much. So ground and this. All right, I wouldn't be surprised if those were actually shorted together, but I'm gonna take a look close at pins 10 and 11 to see if there is a bridge there. All right, so we got to look at 10 and 11 real close here. All right, so we're talking here and here. I don't see anything bridging on the pad. And nothing on my fluxy mess of soldering there. Alright, so it looks like this pin and this pin are shorted together. This is pin 10 and 11. Pin 10 is ground for the entire system. That goes to the battery ground. And pin 11 is a ground connection for the EEPROM that stores the high scores, or high score. I don't know. I'm not planning on using the EEPROM on the board because the micro I'm going to use has built-in memory. So I might just let this go. I don't know, I can't think of a good way to figure out if I've bridged it or if it's bridged in the circuit without removing this board, and there's no way I'm going to do that. I do have another machine that I could take apart and test to see if it's bridged there, but I really don't want to take that one apart. That's the one I play with, not the one I tear up. So I'm going to let this go. I'm going to see what happens.
So I've put the playfield PCB back into the playfield, and my next goal is to get the power supply powering the battery box, which is powering the playfield, and then connect the playfield with this ribbon cable to my microcontroller on my breadboard. And what I'm hoping to do is recreate the same situation that we were in at the end of the last video, where I was able to drive the score displays from my microcontroller using the playfield circuitry. So I put the ribbon cable on, and I was going to place the battery box over it so I can connect this connector to where the power comes in. And I couldn't because of these posts that were sticking out. And it's interesting because there's a pretty strange thing to have sticking out the bottom of the battery box. The reason for it is there's two pads right here labeled Sen 2 and Sen 3 that look like part of maybe the acceptance test procedure from the manufacturing is when everything is assembled to stick two probes through those holes so that they make contact with those two pads. And I'm guessing maybe those are connected to power so they can check the output of the power regulator, or the voltage regulator. But anyway, with this ribbon cable here, I'm probably going to end up cutting these off because I can't really route the ribbon cable this way because there's this the scoop has a lever right here, and I don't want to interfere with that. So I'm going to have to route the ribbon cable maybe like this to get it. I'm not even sure where I'm going to put the micro yet, but hopefully there's room in here somewhere. I have to work around the motor that sticks up here. So anyway, the ribbon cable has to go this direction, and I can't put the battery box down because of these little tunnels for the test points. So I'll probably have to cut this off to give myself room for this cable. It's just kind of cool to figure out what this thing is for. It's so that when they put the probes down, they don't, make contact with any of the other circuitry that's around there. They only hit those test pads. Ta-da! Alright, let's see if it fits now. When I measured, it looked like I had just enough space. Looks like that's the case. So a bit of a moment of truth here. I've got power, alligator clips hooked up to the battery box. I've got the ribbon cable routed out to hook up wire to the breadboard. Cable side of the connector is on the right. Non-cable side's on the left, so I swapped it. And 6th and 7th pins up are power, so I've got those connected right there. I'm going to fire up the power supply at 4.5 volts, which would be the equivalent of the 3 C batteries, 1.5 volts each, making it 4.5. And at this point, I really just want to measure that voltage there. Well, first, make sure that it doesn't go up in smoke. Second, measure the voltage there and make sure that I'm getting it's been so long now, 3.3 volts, was it? I think the voltage regulator steps it down. I kind of forget what I'm expecting though, but we'll see. We'll see what happens. So 4.5 volts. That on negative. This on positive. no current draw because it's not powering anything, because it's not hooked up to the microcontroller. And we'll see what we get over here. Not what I'm expecting. Oh. I think the battery box is turned off. Let's turn that on. I did this last time too. Ugh. I can find the switch. There it is. Now let's see. There it is, 3.5. So it didn't go up in smoke. That's a good sign. Alright, so while I've got things powered up, I wanted to do a little experiment. I've hooked up hookup wires to BP24, which is LEDs H and F, and BP00, which is LED L. I had LED L labeled as a sync, so it wants to sync power to enable the LED. So if I hook up BP00 to ground, it should turn on LED L, which is this one. So I'll do that now. It is this cable here, this wire here. There we go. LED L right there. The other one is LED HF, and I think I had this wrong. I had it marked as a source, so I would want to hook that up to power LEDs H and F. And I did that briefly and it didn't work. So then I hooked up and measured. I was thinking maybe it's not a source, maybe it's a sink. Maybe I need to hook it up to ground. I didn't think that was the case because if you look really close, BP00 has parentheses around it, which makes me think that it would be have a line above it, which means you want to ground that pin to enable what it's controlling. And BP24 does not. And looking at the circuit here, what we're talking about here is these two LEDs. And you can see the pin routes to a resistor, and then presumably a transistor of some sort. One side of the transistor is power. I was assuming I would need to provide power to this leg to be able to pass that power to here, but that's not the case, because when I briefly connected this line to power, nothing happened. I think now what I need to do is connect this other leg to ground to enable this, which would provide power to that LED and also to this one, grounded through the ground connection here. So let's hook this up. Well, I can see if I measure voltage. I'm seeing voltage on it, and actually, I don't know if you can see it there, but the lights light dimly. So I think I've got this wrong, and what I need to do is connect this pad to ground to enable these two LEDs. So let's try that. Connect this to ground real quick. And there we go. LEDs H and F light up. So that's cool. I've been able to test out, just a couple pads, 4. I know that my power and ground for the system is good. I know that at least LED L and LEDs H and F are good, although I had that wrong. It's a sink, not a source. So I went ahead and done that with the rest of the lights that are controlled by the microcontroller directly, not including the ones that are controlled by the slave microcontroller in the back box. So those are the ones shown here in yellow. H and F, the 2 pops, 2 posts, so one kind of GI light behind the Sano target, and the top 2 of the bonus lights. The rest of the LEDs are controlled by the back box. Alright, so I've got the Teensy hooked up, ground, and 3.5 or so volts from the regulator on the playfield board. The SPI pins, 3 pins MOSI, and clock and chip select here, going to the playfield connections here. The only thing left to do is apply power to the 3.3 volt connection on the Teensy, and we will see what happens. Make sure I don't get this one wrong. 1, 2, 3. There we go. All of the playfield lights working. The ones that are blinking are the ones that are controlled by the smaller micro in the back box. You can see all of the lights on the playfield work. The 3 LEDs on the back box all work. And all of the score digits work. Excellent. So everything is being controlled by the Teensy, which is running off of the playfield's power supply, the playfield's power regulator, which right now is powered by my bench supply, but eventually could be powered by 3 C-cell batteries, just like the original unit was, supplying the same 4.5 volts. So, what's next to look at would be getting these switches functional. So all of the 3 pops, 2 stand-ups, 2 slings, getting those working. And also the optical switches, the trough, the shooter lane, and the scoop, getting those working. So I'll see you next time, and we'll tackle those switches then.